Hello, students. Today's date is the 25th of August 2020, and today we are going to go over the Big Bang Theory. No, we are not going to be talking about this ridiculous TV show that we see over here to the right. Our objective for the day is to explain the formation of the universe and its fate. And let me slide this over here. Okay, so our Big Bang Theory. All of the energy and matter of the universe originally existed in an incomprehensibly hot and dense state. This was about 13.8 billion years ago. Our universe began as a cataclysmic explosion, and it has continued to expand, cool, and evolve until what it is now. After the Bang, only subatomic particles existed. Okay? Today, almost 400,000 years for these particles to form atoms, such as hydrogen and helium. These were because those are the two lightest elements that we have, they formed relatively quickly compared to everything else. As the universe cooled over time, primordial gas condensed into the first stars and our first galaxies. So we had this very dense and very, very, very hot stage in our universe. Well, at the very beginning of the Big Bang Theory, it was very hot, very dense. Okay, this was billions of years ago. There was a bang. It began to expand and cool. That's how we end up with our universe today. The first stars. Okay, our sun is a star. Okay, it is not the biggest star. It is not the smallest star. It is actually a very regular kind of a star. But stars and our sun are going to be very similar. Stars formed roughly 200 million years after the Big Bang, and they are made of primarily hydrogen and helium. Once again, those are the two lightest elements, so they are very easily made through this process. There's an abundance of them. Abundance meaning that there is a lot of hydrogen and a lot of helium available to make stars. Now, generally, monster-sized are 30 to 300 times larger than our sun. So our sun is actually a very regular-sized star. There are much, much, much larger ones. Bigger stars will have shorter lives. This is going to be important because our sun is very medium-sized, it will actually have a pretty decent lifespan for how long it's going to be able to support life on Earth. And then during life and death, stars synthesized heavier elements and spewed them into space. So, our universe is expanding. In 1912, Vesto Slipher from Arizona was the first to discover that galaxies are always moving. Okay, they rotate as well as move in space relative to each other. So our Milky Way galaxy is moving. In 1929, Edwin Hubble noticed most galaxies were moving away from us. Okay, this is going to go over Hubble's law, which galaxies recede at speeds proportional to their distances from the observer. And the last part, this was a huge shift in ideas, where everyone thought the universe was static and unchanging. Here are some predictions based off the Big Bang Theory. In 1965, scientists found evidence of cosmic microwave background radiation. They come from the initial unimaginably hot universe prior to the Big Bang. As the universe continues to expand, these electromagnetic radiation waves that have high energy have now been stretched out to be barely detectable. Now, here's the fate of our universe. Okay? We have two possible scenarios for what will happen in the future. The Big Chill, which is the universe continues to expand, it continues to cool, and will no longer be able to support life. Or the Big Crutch, which is the opposite of Big Bang. As the universe expands, it will attempt to bounce back to become dense and bring the universe to a collapse. Okay? So the Big Crutch is we have it stretched out, we have a rubber band stretched out. Okay, when I let the rubber band go at both ends, it is going to snap back together. So, as we look over here at the models of our expanding universe, let me move just a little bit forward so I can explain this. Right here at the very left, okay, this is our past. This is where the Big Bang started, okay? A dense, rapidly decelerating universe. It's going to decelerate. It is going to be, this is where we're at present. We know that this is what our universe looks like now, okay? And it's going to begin snapping back into just kind of a crunch, okay? Is going to snap back like a rubber band. Now, a sparse, slowly decelerating universe, excuse me, Mr. Forker, this sparse, slowly decelerating universe is going to start off. We know that it started off at the Big Bang. It is going to expand, and it's going to keep expanding. Okay, but it's going to expand very, very, very slowly. An empty, freely expanding universe is going to start like this, and it is going to expand slowly, and then it's going to get very big at a more linear rate, but not as slowly as the sparse, slowly decelerating universe. Now this is decelerating, then accelerating universe. So it's going to get big and then kind of start getting small again, and then it is going to get big very, very, very quickly at an exponential rate. So if we think about our functions in math, if we think about our graphs in math, a linear function is going to be a straight line, much like this third one right here. Now, an exponential graph is going to, well, it is going to accelerate at a rate that is going to get very big very, very, very quickly. These are the possible fates of our universe. Now we have something called dark matter. Our universe has 100 billion galaxies. That is a billion with a B. Each with billions of stars, clouds of gas and dust, planets, moons, and other debris. Sorry, someone was waving at me. The closer to the galactic center, the faster the galaxies should be moving. You can think of this like Venus, how it travels around the sun faster than Earth because it is closer to it's closer to our sun, so it has less distance to travel around it. We'll go over that in the solar system unit, which will be our next unit. Now, scientists think that dark matter is the cause of everything in the galaxy moving at the same speed. No one knows what dark matter truly is, but we think it is what is tugging on the stars, keeping them at an even pace, because everything is moving, but everything moves kind of at the same pace to give this illusion that really things aren't moving, but our universe is expanding. 25% of the universe is made up of dark matter. It doesn't emit or absorb light, but still interacts with the things we can see. So once again, dark matter is going to be kind of a very it's a complicated topic. I'm not even gonna lie to you guys. It is complicated. Okay, I misspoke on that last part, so there's a little bit of that. I apologize. This slide is actually called dark energy. I previously said dark matter. That is not correct. It is dark energy. So if this video is a little bit choppy right there, I apologize, but we're just going to keep plugging through it. So dark energy. In the 1990s, scientists thought gravity was going to slow down the motion of the universe expanding. That's not true. The universe is actually speeding up. In order to explain this, scientists came up with the term dark energy to explain a force they had no idea about. We have no idea if dark matter and dark energy are related. We have absolutely no clue. The kind of cool thing about the universe is that there's still lots of things that have not even been discovered yet, and a lot of phenomena that have not been explained. For example, this dark matter right here. We have no idea what this actually is. We just have no clue. But it's kind of cool. The scientists will come up with terms like this in order to explain phenomena that they do not understand. They are trying once again, they're trying to make sense of our natural world. Just like we talked about last week when we talked about the scientific method, they're using that to explain what dark matter and dark energy are, and they're trying to figure out why this is happening and what it is and why and how does that relate to us. All right, and then here's a little YouTube video that you guys are gonna watch. Here's the link up at the top. Like always, I kind of try to provide you guys videos to supplement what I have talked about. That's what I got for you guys today. So here's what we should be doing. We should be making sure that we did our warm-up today. We should be making sure that we did our DOL. Remember, if you're watching this video, I don't know if you're watching this video, so I need you to do your DOL so I can mark you as present for the day. Remember, those are kind of due by about 4 o'clock, 4:15. I submit my attendance pretty much right at 4 because I got to go coach afterwards. So please get your video, or not your video, please submit your DOLs. Please get them done. We have way too many of you guys that are not completing it, and you're being marked absent as a result. So please get this taken care of. There'll be another video this week going into the next part of our content. Have a great day, Stallions.